Hello everyone. In this video, I am going to be going over allowing the window to resize. And currently, our game can't do that. And when we do resize, it leaves this big emptiness here. And we don't want that. I mean, you could go the cheap way and keep the window non-resizable, but it'd be nice to be able to resize our window. So let's get started. In the window, this is where we're going to start. In the window, we're going to add a couple of different methods and variables, and adding to a couple methods as well. So the two variables we're going to need is a private boolean, and I'll call this hasResized, and a private glfw window size callback. And I'll call this Windows size callback. Not what I wanted to happen. Alright. Okay, so now that we got these two here, in the window, I'm going to set hasResized to false. Then I'm going to come down to update, and before we update glfw poll events, this doesn't matter if it's below input update, we're going to set hasResized to false. And that should be it for now for editing some of the methods. And now we're going to create a couple of methods here. While we're still down here, I'll create a method that returns a boolean, and it'll be called hasResized, and it'll return the hasResized variable. Now I'm going to come back up here so the callbacks will be in the same spot. This is going to be private void set local callbacks. And here we're going to set window size callback to a new glfw window size callback. The only method we're going to be using is invoke. Now you may have these as your variable names, so I'm going to go ahead and change them so it would be more easier to know what they are. And the first one, I'm going to call it org window. The second one will be called org width. And the last one will be called org height. All we do is just set the width to org width, and then height will equal org height. And we'll set hasResized to true. So now we've created our callback here. Well, that doesn't mean that invoke is going to be called. We need to send this to glfw, so glfw knows that this exists, and it'll call it when it needs to. So all we need to do is glfw set window size callback. We'll pass in the window, and we'll pass in window size callback. Now glfw knows about our callback. So, that's not all. Just because we have it set here, that doesn't mean glfw is going to know about it, because we're not calling this method. So, in the create window method, right at the very end, we'll call set local callbacks. And that should be it. And if you want, which you probably should, is have a public void cleanup. And then this will just clean up any loose ends that we make. In this case, we'll be cleaning up our callback here. So window size callback close. Alright, we should be done with the window. And now let's go into main. So now that everything with the window is now done, we can just test this in the update method. Or not the update method, but the update loop here. So here, I'm going to type if window has resized, then we'll just use gl viewport 0, 0 window get width and window get height. And this should work, but there's also going to be a problem with it. It works, but notice how everything's all being stretched out now? Not only that, the player's not, well, the player is sort of centered. Let me give the program a bigger level real fast. Okay, so I'm back. I've just expanded the world a little bit. So now we have a little weird thing down here. And we got ourselves a little bunny right here. Yeah. Okay, so right now when we expand the game here, it gets all stretched out. That's not what we want. It doesn't look good. So, one way we can achieve this is by changing the projection that the camera has. So the camera, if I remember correctly, doesn't have a method that allows us to do this. So we're going to have to create a method for it. And yep, I'm correct. And this is very simple. Set void set projection int width int height. I'll just cut this and paste it here. And I'll just call set projection from the constructor. So that's it for the camera. Basically, this method allows us to set the projection whenever we need to. And in this case, when the window has resized, we're going to need to change the projection. So go ahead and type in camera set projection to window get width and window, oh, if I could spell it right, window get height. So now, when we resize our window, nothing should be stretched. But however, we do get some of the emptiness, which isn't very particularly good. And this is a problem with the world. Right now, our world has a fixed view distance pretty much. So that's what's causing the empty space now. And we're going to need to change this. So I'm going to create a new method, and this is going to be called public void calculate view. And it's going to take a window, well, yeah, I'll have it take a window. Okay, so now that we have calculate view, we're going to need to calculate all of the views. So before I do this, I want to separate the view variable into two separate variables. One controls the x-axis and one controls the y-axis. So I'm going to get rid of final here. I'm just going to call that view x. And the next one will be called view y. Alright, so back down here in the calculate view, basically we're going to take the tile scale, multiply that by 2, and divide it by the window size. And this will pretty much give us how many tiles can fit onto one axis. So for the view x, this will equal to the window width, so window get width divided by the scale times 2. Now I'll just copy that because it's the same with the y, except it's view y equals window get height. Now, if you're going to stick with one variable, then I would recommend setting view or having these as two different integers here, and then setting view to this pretty much. Right here, we'll max it out and add 4, because if you don't add 4, you'll be able to see some tiles appear in and out of existence, and you don't want that. But since you have 2, or I have 2, I'm not going to be needing that. Now comes this part, rendering the tiles. And currently, we are rendering them wrong. Well, not wrong, it works, but there is another way. And it doesn't require the window. It doesn't require the window. So I'm going to take out window from this method. And we'll get on to everything now. And essentially, we don't need this in the algorithm. We don't need anything that has to do with the window inside that algorithm. It's useless, so take it out. So this is giving us the X and Y position of the camera scaled up to the world. So it'll give us the position of the camera relative to the world. And all that's left to do is change these so they work correctly. View X and view Y. And we're going to get the tile. It's close, but instead we're going to subtract view divided by 2, or view X divided by 2, sorry, plus 1. So this would give us the actual center of the camera here. And the same on the Y, except this one's just going to be minus view Y divided by 2. So now we have exactly that. So we have the exact tile we need. Now we just need to render it in the right position. And it's pretty much the same thing that we're adding. Minus view X divided by 2 plus 1. And this time on the Y-axis, we are adding view Y divided by 2. Now, we can run this, but we're going to get some errors here. So first, I'm going to get rid of the window here. And when we create the window, or not the window, when we create the world, wherever that is, oh, there it is, we want to call world calculate view and pass in the window. So currently, this will work, sort of. We're getting there. Now when we resize the window, it's actually still in the center, much like it needs to be, versus when we did before, it wasn't very centered like it's doing right now. It stuck itself to the far left of the screen. And changing the algorithm to render the world basically changed where the tiles are rendered, and this is where we want the tiles to be rendered. So when we resize the world, notice how we're still not rendering as many tiles as we need? Well, this is because we need to recalculate the view. So back down where we have if window has resized, after we set the camera projection, well, it could be before, but still, we're going to add world calculate view and pass in window. So far, so good. Let's resize the window here. And there we go. Look at that. It's getting there. We'll have to mess around with the view for a little bit. I mean, it resizes right. We just need to add a few values. So in the world, when we calculate the view, I'm going to add 2 to both of them. So now, it'll render all the tiles that's shown. Oh. Huh. Well, that's weird. Oh, it's doing it for the Y too. So remember when I said you had to add 4? I guess you still have to add 4. Because it didn't do that to me when I first implemented this to make sure everything worked. But now it wants that. That's weird. But anyways, now it works. We can have the window at any size. The player will be centered in the window, and everything works. And that's pretty much it. This was a long video, but I didn't want to separate this into 2 videos. Yep, and that's pretty much it. So now that we're able to resize the window now, you can go up to any resolution you want. But there's a downside, because when you resize to a big resolution, it'll eventually get to the point where the tiles are so small that you can't even see it. Well, in the world, just change the scale. That's all you have to do. So I'll change the scale to 32 by 32 here. And it still works. We can resize the window, and everything still pretty much works the way it should be. I hope you guys enjoyed this video.